Okay, so we're going to solve this problem that presents some difficulty for us because we have not enough information to use the ideal gas law up front. So it says, at what temperature will nitrogen gas have a density of 1.13 grams per liter at a pressure of 1.09 atmospheres? So I can see with atmospheres that I also know that my R should be 0.0821. And I realized that in order to use PV equals nRT, right now I have pressure, and I'm trying to solve for temperature, but I'm missing V and N. So I have V, I have R, I'm missing V and N. But I can see that if I know that it's nitrogen, I know then that the molar mass is 2 times 14.01. So I know that the molar mass is 28.02 grams per mole. And at this moment, I can see that I have an associated mass and associated volume. So one way to manage this is to say, okay, I'm going to assume that I have a volume equal to 1 liter. If I assume that the volume is equal to 1 liter, then I know that my mass has to be 1.13 grams based off of the density. If my mass is 1.13 grams, then I know, because I know that it's N2, that I have 28.02 grams of N2 per 1 mole of N2. And in that calculation, I have solved for N once I go to do that, which means I now have N, and I have V, and I have P, and I have R, and that's going to let me then solve for T using PV over NR. Plug in all your numbers, include units, think about sig figs, and you're on your way. You could also make the assumption that you have 1 mole to begin with, and then take the mass of 28.02 grams and use the density to solve for the volume. It makes no difference which assumption you make. You just should make an assumption that's easy, and you need to make sure that you show the work and follow through to show where you're getting your numbers from. And you should indicate that you're making an assumption to the person who's evaluating your work. Another way to solve this problem is to do what are called derivations. So when we look at the ideal gas law, PV equals nRT, we might notice that we have N here. And that N, we know, comes from mass divided by molar mass. So we could make that substitution. And if we cross up our molar mass, we end up with a derivation of the ideal gas law that when we've been given mass and molar mass, we could solve. We also, at this point, might notice and realize that we have V and we have M. So if we bring the V over, we have M over V now equals RT. And we realize that M is density, which gives us an equation of PMM equals DRT. So now you have 3 derivations of the ideal gas law that you could use arguably a little more efficiently. But for some students, this requires some memorization. That is a little bit problematic, and sometimes you freeze up on a test and you don't remember this. Whereas if we look back here at making an assumption, you can see that it only relies on the ideal gas law, and it's just about applying some understanding of how density and molar mass interplay. It's technically your choice. What you need to do is pick a method, and you need to stick with that method, and you need to practice that method with test-worthy work.